Welcome back. Let's continue with our concept map. We said we'd start with perpendicular lines. So let's look at angles that are formed by perpendicular lines. I have line AB, which meets line CT at point O. That's how we label the lines. From the beginning, you use the first letter, and at the end of the line, you use the next letter. So line AB meeting line CD at point O. We are labeling the intersection as point O, and they meet at an angle of 90 degrees, and that is a right angle. I think you are able to identify with that black box there. So those are perpendicular lines according to the definition that we had read. Let's look at how they would look in a shape. There is a rectangle. A rectangle is an example of a shape that has 4 straight parallel lines and 4 right angles. Looking at that, I've got a rectangle A, B, C, D, and I have 4 right angles, and I have that side which is longer and the other side on the opposite side which is same length. I have that side AC and side BD, which are equal as the width of that rectangle. So again, you would see that BD is a line that meets AB at that point, and they form 90 degrees. So the knowledge of perpendicular lines continues even when we're dealing with shapes. And each side of the rectangle is perpendicular at 90 degrees to the adjacent side. Let's move on. Again, let's look at, continue looking at perpendicular lines. When 2 lines form an angle of 90 degrees, we say that the 2 lines are perpendicular, and we would then use that example AB and CD. Line AB and line CD, we use that symbol there as perpendicular. That's how we write perpendicular. So when we read that sentence, it would be AB is perpendicular to CD. That symbol shows that they are perpendicular and that they form an angle of 90 degrees. That is the knowledge we know now. When they are perpendicular, they form an angle of 90 degrees. Let's look at a typical example in that regard. I have a figure there, lines intersecting. I have AB and CD intersecting, and I have line, let's make that intersection O. I have line OE forming an angle of X and an angle of 25. And the question says, if in the diagram above AB is perpendicular to CD, that's information that they are sharing with us, and then use this information to determine the size of the unknown angle, angle X. Now look at that. Where is angle X? It is adjacent to angle 25. And what do we know with the information that they have given us is that line AB is perpendicular to line CD. Because of that, we then write the statement X plus 25 equals to 90. Why do we use 90? Because it was not given there, because they gave us the word perpendicular, and perpendicular lines meet at 90 degrees. So that statement then is true. And therefore, now we then say X plus 25, we minus 25 as the additive inverse equals to 90 minus 25, and then our value of X is 65. All right? Let's look at another. Here's another question. Solve for X and then state which lines are perpendicular. There's a triangle and it's 2 triangles combined. However, we are dealing with, we are dealing with perpendicular lines, which means we want to see what happens to angle X because it is the angle where the lines intersect. What do we know? What we know is angles of a triangle equal to 180. So when we add 60 degrees plus 30 degrees, which is information that we know, and then plus X, it would give us 180 degrees because the sum of angles of a triangle equals to 180 degrees. So now that we have that statement, we then combine 60 and 30 and they give us 90 plus x equals to 180. We subtract the 90 so that we remain with x. And what we do on the left, we also do on the right. So we also subtract 90. And then x, 180 minus 90, leaves us with 90. So our angle x is 90 degrees. Now we can firmly draw a box that says x is 90 degrees. Therefore, those lines are perpendicular. Line DM is perpendicular to line EG because of our proof there. All right, let's look at another one. We've got lines that are intersecting below line LM, and we are to prove, okay, we are to solve for angle X first. Let's solve for angle X. We notice that all the angles there are in a, let me rub that off before I cancel it. All those angles are on a straight line. Therefore, let's add them all up. It would be angle 72 plus angle X plus 33 degrees plus 17 plus 40 equals to 180 because they are all supplementary angles. So 72, let's use our calculator, and we have 72 plus 33 plus 17 plus 40, and it gives us 162. So it is x plus 162 equals to 180 degrees. And then we subtract 162, additive inverse, and what we do on the left, we also do on the right. We also subtract 162, and then 180 minus 162 would give us 18 degrees. So our x would be equals to 18 degrees. That is the first part. We've done A, which is we've solved for x, and our value of x is 18. Now prove that LM is perpendicular to KJ. Perpendicular means 90 degrees. X is 18. Let's see. 72 degrees, this is number B. 72 degrees plus 18 equals to 90 degrees. So if 72 plus x equals to 90 degrees, therefore, then we can then say JK is perpendicular to LM, because when we add the two angles, they give us 90 degrees. All right. Let's look at another section of our concept map, which is intersecting lines. Look at angles that are formed by intersecting lines. Intersecting lines are lines that meet and cross over each other. And when lines intersect, there are angles being formed. In this case, we have two lines that intersect, and you'll realize that I have an angle there, an angle there, and angle that side, and an angle that side. So I've got four angles, angle A, B, C, and D. And angles that face each other are equal. The angles are vertically opposite. Let's look at which ones are those. That would be angle A and angle C are vertically opposite. Look at it as if the angle is an arrow. It's always easier to remember when you are looking at angles that are vertically opposite. You look at it as if it is an arrow, so that angle there moving that way and that angle there that way. So those two angles face each other. And because of that, they are said to be vertically opposite, and they are therefore equal. And if A and C are vertically opposite and equal, that also makes angle B and angle D to be vertically opposite and equal. All right. Let's continue looking at intersecting lines. Now we are looking at lines that intersect at O. I have line AB with line C, O, and OD meeting at point O. And as they meet, you also notice that there are three angles being formed. Angle 1, angle 2, and angle 3. Just for you to know how angles are named, angle 1, we can name it as O1. Angle O1, we can write it as that. And the other one will write as angle O2. And the other one will write as angle O3. That's how we separate them. Another method of writing angles, so that you know, even when you write an exam and you find it written differently, you would know what it means, is angle, we read it from the beginning of the line, it's angle AOC. So it would be angle O1 would be written as angle AOC with O having a hat, and that O means that that is the part that becomes the angle. So that, let's look at the next one. It would be angle COD. So it would be COD, and O will be the part that has a hat. That reflects that it is angle COD. The part that is in the angle is the one that is in the center. And then the last one would be angle DOP. So the other one would be written as DOP with the hat on top. It's only then that it becomes an angle. That is the symbol of an angle. So the angles are on a straight line and they are supplementary. Now that's another word we need to remember, that they are supplementary because they are on a straight line, and in this case, these angles will add up to 180. Two angles that have a common vertex and a common side are then called adjacent angles. So now we have supplementary adjacent, which means angle O1 and angle O2 are adjacent because they are separated by one line and they have a common point O, and therefore they are supplementary adjacent. But angle O1 and O3 are not supplementary, are not adjacent, sorry. They are supplementary because there's angle 2 between them. However, the adjacent ones are angle 1 and 2 or angle 2 and 3. So, however, when we add angle 1 and angle 2 and angle 3, we have 180, and we call them supplementary angles. Let's look at a typical example of supplementary angles. There is a line with two angles. One angle is 63 degrees, the other one is angle A. So we are to determine the size of angle A. And what happens is whenever we make a statement, we need to put a reason why we are saying that. So we are then saying when we add angle 63, which is that one, and angle A, A plus 63 equals to 180. That is a statement we are making. As we make that statement, we need to substantiate with a reason. And the reason would be these are supplementary adjacent angles. That's why we are adding them to give us 180. When we have already made our expression, now we take the expression and we put an additive inverse. The number 63 is the one we need to eliminate so that we remain with A as the unknown. And what we do on the left, we also do on the right. And 180 minus 63 degrees will then give us 117 degrees. So that is our value of angle A. Let's look at another one. Determine the size of Y. Again, it's a line that intersects and forms an angle there and an angle there. Both of them would give us 180. So we can follow the same pattern and say Y plus 95 equals to 180. That is the statement we are making. Why are we saying that? Because these are supplementary adjacent angles. Adjacent angles. And Then we want to isolate y as the unknown so that we have all the figures on the other side or on one side of the equal sign. So then it would be y plus 95 minus 95. Remember, additive inverse is opposite sign, same number, and it would be 180 minus 95, and then that would give us y is equals to 180 minus 95 is 85 degrees. So that is our value of y. And let's look at the next one as well. Determine the size of x. There are three angles there. It helps to always understand that this is an angle, this is another, and that is another. So I know that I'm dealing with three angles. When I add them up, I need to add three numbers, which is 51 degrees plus there's a box, and that box we know equals to 90 degrees, and x, and they make up 180 degrees. Reason is they are supplementary angles. Again, you'll realize that I'm not using the word adjacent because I have three angles there, so I'll then use supplementary angles. And therefore, 90 plus 51 becomes 141. Let me rub that. 141 plus x equals to 180. And then we eliminate 141 degrees minus 141 degrees plus x equals to 180 degrees minus 141 degrees. And then we remain with x on this side, and on this side we have 39 degrees. Let's stop there for now and go for an ad break.